All right, so here we're just going to look at some properties of operations, specifically these properties of equality within them. So I'll kind of explain it through this first example. If 5y equals 25, which property of equality was used to keep the equation 5y minus 7 equals 25 minus 7 equal? So we're looking at properties of equality, and that just means that this equation was changed from 5y equals 25 to 5y minus 7 equals 25. But then it was 25 minus 7 too. So on both parts of the equation, on both sides of this equal sign, they subtracted 7. It's kind of like say you had a balance scale, right? And over here you had 5y, and over here you had 25. Well, right now, this was already equal. So this was already equal and was balanced nicely. But then we took away 7 over here. So what likely would happen if you took away 7, this side will go down. But wait, if I take away 7 over here too, it'll balance back out and it'll be equal again. So in this case, the property of equality that was used would be subtraction. So this was used the subtraction property of equality. But guess what? There's 4 operations. We add, we subtract, we multiply, and we can divide. So it says, what other operations of equality could you apply to keep the equation 5y equals 25 equal? Give an example of each. So there's 3 others. We could add, we could multiply, and we could divide. So an example of each. Okay, so 5y plus, let's just go with 7, would equal 25. And you just have to do the same thing. So plus 7. Again, it's like a balance. If I add 7 here, I have to add 7 here. And then next I need to multiply. So I could say 5y, and I would just put this in parentheses and say, okay, this can be 5y, we'll say times 7, would equal 25. And again, just multiply it by 7. So I multiply by 7 here, multiply by 7 here. So this is the multiplication property of equality. This one's going to be your addition. The subtraction one was up here. And we're left with one more, division. I actually would not even use this symbol, but I would do it a little bit different. So in this case, we have 5y equals 25. And I could do 7 again, but for this one, I'm going to do something a little bit different just to kind of take it a step further. I'm going to do 5. Just watch what might happen. So in this case, I set it up like a fraction, 5y divided by 5, and 25 divided by 5. And as it turns out, you can actually take this property of equality and you can use this to actually solve. So if I have 5y equals 25, but then I divide both parts by 5, over here, that's going to cancel out. What I mean by that is 5 divided by 5 is 1. So this here becomes 1y, and 1y is just y. And that's going to equal 25 divided by 5. And 25 divided by 5 equals 5, in which case you can solve for it using the division property of equality. And how do you know to use division to figure out what y is? Well, it's because in the actual algebraic equation, it's using multiplication. It's saying 5 times y. So you just use the inverse operation, which for multiplication is division. And you can use that and actually figure out what y is. But anyways, purpose of this lesson is just to understand that there's 4 properties of equality, and as long as you do the same thing on both sides of the equal sign or both parts of the equation, it'll stay equal. So whether you add 7 to both sides, subtract 7 to both sides, multiply 7 by both sides, or divide both sides by 7, or in this case I did 5, it'll keep everything still equal. And